7.2 is called substitution, and in this section we're going to learn to use substitution to solve systems of equations. So we're still dealing with systems of equations. They're going to be equalities this time, and before we were solving them by graphing, now we're solving them algebraically with substitution. So we're always going to start out with two equations. My first equation is y equals 2x, and I always write my two equations to the left and right of each other. The other equation is 4x minus y equals -4. So I have two equations, and I'm going to start by making sure in either one of the equations I get either an x or a y alone. So in either equation, I need to get an x or a y alone. Well, this equation already has y alone, which is going to make this one a little easier. When y is alone, you're going to take parentheses and put it around what y equals. So the whole thing to the right of that is what y equals. I put parentheses around it. I go to my other equation, I put parentheses around my y. So my y equals 2x, and I'm going to substitute it in right here for what y equals. So I'm going to write 4x minus, instead of the y, right here, I'm writing what it equals, 2x equals -4. And then I'm going to solve this equation for x. So 4x minus 2x is 2x equals -4. Divide by 2, x equals -2. After I have my x, I need to take it and go back and substitute it in, go back and substitute it into either equation for what x equals. So when it says y equals 2x, I'm going to change that x to what I know that y now equals. So y equals 2 times -2, so y equals -4. I'm going to write my answers as ordered pairs with the x first and then the y. My x was -2, my y was -4, and the first one is solved. That's the answer to my equation. If I had been graphing these, I would have gotten two lines somehow cross, and the point where they cross, where they intersect, is this point, -2, -4. Okay, next example. In the next example, I'm going to start out with x plus 3y equals 7. My other equation is 2x minus 4y equals -6. Once again, I have to start by getting an x or a y alone in either equation. So I'm going to need to find one that doesn't have a number in front of it. Otherwise, it's going to be really hard to get it alone, and it's going to get real messy. So looking at all my x's and y's, the only one that doesn't have a number in front of it is right here. Therefore, that's what I need to get alone. So of all the variables that you see, you're going to find one that doesn't have a number in front of it, and that's the equation you'll start with, and you'll get that variable alone. So to get that alone, I just need to subtract 3y. I get x equals 7 minus 3y. I know what x equals now. It equals 7 minus 3y. I put parentheses around it. I go to my other equation. I solved for x. I know what x is, so I put parentheses around x. I take this and substitute it in. So I have 2 times 7 minus 3y minus 4y equals -6. That will give me 14, I'm distributing, minus 6y minus 4y equals -6. You have a choice now. You could subtract the 14 if you want. when I subtract the 14, I have negative 6y minus 4y equals negative 20. I'm going to combine these like terms. Gives me negative 10y equals negative 20. Divide both sides by negative 10, and y equals positive 2. I've got my y. I'm going to use this equation, x equals 7 minus 3y, and I'm going to substitute in what I know that y now is. So x equals 7 minus 3 times 2, x equals 7 minus 6, x equals 1. I'm going to write my answer as an ordered pair, the x first, and then the y. And then the second problem is done. Next problem, let's do x minus 2y equals negative 1, and the other equation, 3y equals x plus 4. I need to get, you can try to do this one on your own if you'd like. Put me on pause and give it a try, see how it works. I need to get an x or a y alone in either equation. So this time I have a choice. I could either get this x alone or this x alone. Doesn't matter which. I'm going to start on the left and get this x alone. So I have to add 2y to both sides. I end up with x equals negative 1 plus 2y. I now know what x is, and I'm going to go to the other equation, find x, and substitute it in. So I have 3y equals negative 1 plus 2y plus 4. Now my parentheses aren't doing anything, so I'm going to get rid of them. And now I'm going to get my y's on the same side. So I'm going to subtract 2y. That gives me y equals negative 1 plus 4. So y equals 3. I'm going to go back to this equation, x equals negative 1 plus 2y. And I'm going to substitute in the y. X equals negative 1 plus 2 times 3. X equals negative 1 plus 6. X equals 5. So my ordered pair is 5, 3. Okay, let's try another. In this next problem, the first one is 2b equals 6a minus 14. The other equation, 3a minus b equals 7. Once again, so I'm dealing with a's and b's. The only difference is in the end, I'm going to have my a and then my b in the ordered pair. So once again, I've got to get an a or a b alone in either equation. The only one that doesn't have a number in front of it is right here. It does have a negative in front of it, but I'll have to deal with that. So I'm going to subtract 3a from both sides, get negative b equals 7 minus 3a. I can't have a negative b, so I multiply everything by negative 1 and get b equals negative 7 plus 3a. I'm going to put that in parentheses. I know what my b equals. I'm going to go here and substitute in what my b equals. So I have 2 times negative 7 plus 3a equals 6a minus 14. That's negative 14, distributing, plus 6a equals 6a minus 14. I want to get my variables on the same side, so so I subtract 6a from both sides. And they cancel on both sides. I've ended up with negative 14 equals negative 14. That is a true statement, and therefore my answer is going to be infinitely many. There are infinitely many solutions. And remember back to 7.1, what did that mean about our original equations? If we were to graph them both, they would end up being the same line. So infinitely many is what you're going to write when it comes out to be true, if the variables cancel away. Let's do another. We're going to start this time with x plus y equals 16, and 2y equals negative 2x. 2y equals negative 2x plus 2. So I need to get an x or a y alone. I can get either this x or this y alone. I'll just get x alone by subtracting y. X equals 16 minus y. I know what my x equals, so I will come over here and substitute it in. 2y equals 2 times 16 minus y plus 2. 2y, oh, that was a negative 2. I have a negative 2 on the outside, negative 2. So 2y equals negative 32 plus 2y. So looking back to try to be clear, this was a negative 2 times a negative y. And so that's where I'm getting plus 2y plus 2. So let's see. I'm going to get my variables on the same side. So I'm going to subtract 2y. I get 0 equals negative 32 plus 2. That gives me 0 equals negative 30. My variables have disappeared, canceled out, and this is false. So my answer is going to be no solution. So thinking back, what did no solution mean when we were graphing? It meant that if we were to graph these two lines, they would be parallel lines and they would never, I don't know where they actually are. Okay, I want you to do this one completely on your own. The original equations are x plus 2y equals 0, and the other one is 3x plus 4y equals 4. So you're going to start by getting an x or a y alone in either equation. Go ahead and put me on pause and get all the way to the end and then check your answer with me. So I started by finding that the only number that doesn't have the only variable that doesn't have a number in front of it is right here. So I'm getting that x alone by subtracting 2y. I get x equals negative 2y. I now know what my x equals, so I come over here and substitute it in. I have 3 times negative 2y plus 4y equals 4. Negative 6y plus 4y equals 4. Negative 2y equals 4. Divide by negative 2. So my y is negative 2. Then I'm going to take that, I'm going to go back to this equation, and I'm going to substitute it in for that y. So x equals negative 2 times negative 2, x equals 4. My ordered pair is 4, negative 2. X equals 4, y equals negative 2. Hopefully you got the same answer.